Hello, let's provide answer to this question under calculus. We are to sketch the graph of the function f of x equals to x squared minus 3x and the g of x equal to x on the same axis. And then find the area of the finite region bounded by the two functions. In one of my episode, I talk about how to sketch a curve under calculus. You can visit it and know that I mentioned that the salient point to tackle is one, try to find the intercept on the x-axis, intercept on the y-axis, find the turning point using the differentiation dy dx. If you're able to get these three things done, then you'll be able to sketch the curve correctly. So let's start with that aspect. So since we are going to make use of y-axis and x-axis, we need to change the function f of x to become what? Y. So we let the f of x equals to y, which will be the same as what? X squared minus what? 3x. Which same will happen for this, but let's consider this first. So in this aspect, we are saying y equals to x squared minus 3x. So first of all, let's find the intercept on the x-axis. We know intercept on the x-axis mean what? Equate y equals 0. Meaning the whole of this equation will now be equal to 0. That means x squared minus 3x should be equated to 0. What do? We are seeing x and x, so we can factorize x out. Dividing this will give us x minus the division of this. We also have what? 3 equals to 0. So we can see that this is a product of what? Two numbers that are equal to 0. So it means the first is equal to 0 or the second number. That simply means that your x is equal to 0 or x is equal to what? 3. In the sense that x minus 3 is also equal to 0. Which in this case, the minus 3 transpose become what? A positive. So therefore, our intercept that we are looking for, we know we always pick the x-axis, the point of intercept is x, and y is what? 0. And we also have x to be 3, y is still what? 0. So these are the 2 points we are going to indicate on the graph. All right. Then number 2 is to find the intercept on the y what? Axis. And the intercept on the y-axis simply means that equate your x equals to what? 0. So simply put, we are still using this value, which is y equals to x squared, which obviously will be 0, but let's just have the benefit of the doubt. So we are replacing the x with what? The 0 that we have. And that simply means that y is also going to be equal to 0. Therefore, your point of the intercept will be x-axis being 0, the y-axis being what? 0. So these are the 2 points we need. But also we need to know, since we are having a quadratic equation, there should be a curve, either holding water or pouring water. Simply means curving downward or upward. So we need to find the turning point. So we are going to now find dy dx. Okay, so we are aware that in the dy dx, what do? We transpose the power to multiply. So it's going to be 2x. Then we decrease the power by 1, and now make it 1. You transpose the 1 to multiply the 3, still give you minus 3. Then 1 minus 1 will be 0. So x to the power 0 will produce this. So now we have this. We need to know what value of x we are going to plot and what value of y we are going to plot. So now we let dy dx equal to 0, which is taking the position of the y coordinate. So it means I have my 2x minus 3 now equal to 0, where with all things be equal, transposing your negative 3 to become positive 3, x will now be this over 2 simply means we are dividing by the coefficient, and that could also mean 1.5. This 1.5 is the value on the x-axis. What about the value on the y-axis? We are not going to use the 0 because this is the y dx, not y itself. So now we substitute this into the equation we are working with in order to find the y values. So now we have y equals to the x, which is now 3 out of 2 all squared minus 3 out of 2. Replacing the x with the values we got from the differentiation. So now this is going to be 9 out of 4. You square the numerator, you square the denominator. Minus 3 times 3 will be 9 out of 2. So what do? We multiply both the top and down by 2 in order to make them the same denominator. So this will be 18 and 4. So 9 minus 18 will be negative 9. So we're having negative 9 out of 4, which in this case could also be negative 2.25. So now from here, at the turning point, we can see that the value of x will be, the y value is 1.5, the x value 1.5, the y value is 2.25. So this is what we are going to use for the turning point. So in the sketch of our curve, taking this to be our x-axis, this to be our y-axis, let me just say 1, 2, 3, and 4. Negative 1, negative 2, and negative 3, negative 1, negative 2, negative 3. Let me close and close. So 1, 2, 3, and what? 4. Already we know that the first intercept we have 0, 0. So we know the point is going to be there. The second intercept is 3 on the x-axis, then 0. 3 on the x-axis, 0 on the y-axis. So we know it's going to be here. The third is also this. But we are looking for the turning point. Where will the graph be turning? This is the turning point. So 1.5 on the x-axis, 1.5, and a negative 2.25. So negative 2.25 will be here. So we have this. This simply means that the curve is going to go this way. It will be holding water. So whether it will pass here or here, we need to also know that this is the equation. When x is 1, you put 1 here, this is going to be 3. You have a negative 2 for y. 1, negative 2. You see that it's going to pass through this place. So the curve is coming this way, through here. When we put 2 here, this will be 4 minus 6. That will be what? Minus 2. Do you get it? So it will curve through this place. If x is 3, 3 squared will be 9. 3 will be 9. That will be 0. X being 3, y will still be 0. So it means the curve is passing through here to this place. Right? Let's see if we have our x being 4. 4 here will be 16. 4 times 3 will be 12. And that will be 4 also. So 4. So let's just put the point here. Let our curve pass through there. So we label it as your y equals to x squared 3x. Don't forget we are having two equations, f of x and g of x. Well, we know that our g of x is equals to what? Let's say y equals to x. This is equals to this. Mean y is also equals to this. This is a straight line. So let's just say x is 0, y will be 0 here. X is 1, y will be 1. So it will be here. X is 2, y will be 2. X is 3, y will be 3. X is 4, y will be 4. I think this will have our 4. So the graph is not drawn to scale. So it means negative 1, negative 1, negative 2, negative 2. So our curve, our straight line is just going to pass through this place. So this straight line will be our y equals what? X. It's a find the finite region. This is the area that we are looking for. The area under this curve. So the first one is g of x. The second one is what? F of what? X. So what do? We are going to integrate. So performing integration, we need our limit of integration. The lower limit and the upper limit. The lower limit and the upper limit. So what do? We need to find the point of intersection of the two curves. The point of what? Intersection. So we are going to say that since this is y, it could also mean that x so at the point of intersection, x squared minus 3x will be equal to x, because y is the one that gives us x. It's the same y that is giving us this equation. So we equate them together to mean x squared minus 3x, transposing x to become negative, all equals to 0. I believe you have x squared negative 4 equals negative 4x equals to 0. We can still perform factorization. X out, dividing this, you get x. Dividing this, you get 4. All equals what? 0. From the first explanation, we can say that our x is going to be 0 from this, and this will also be x equals what? 4. This is our lower limit. This is our what? Upper limit. So to find the area, the area is going to be the integral of the lower limit and the upper limit. We are taking the curve above, which is the g of x, minus, we are taking the curve below. We can still continue this, which is going to be f of x, then dx, right? The above equation and the below. So this is going to be integral from 0 to 4. This is going to be x minus x squared okay. You are seeing that this is in bracket because f of x is not a single term, it's a double term. So this negative will have effect on that. So this is going to be the integral from 0 to 4 x minus x squared plus 3x. This negative will cancel this, become positive. Then we have what? Dx. I believe this is x to the power 1. They can be computed together to mean integral of, this will be 2, right? This is 1 plus 3. That will be 4x, then minus x squared dx. So now we can now perform our integration. We increase the power, divide by the power. So the integration is going to be 4x squared divided by 2, this power, minus x to the power 3 divided by 3, the power, spanning from 0 to what? 4. So right here, we do substitution. So your area is going to be, don't forget, 2 will cancel this 2 times, right? So I'll be having, let's say, 2 of the x squared, is that not it? X to the power 3 all over what? Let me still use the integral. 0 and 4, since I am using this to cancel this, right? Good. So now I'll be having substitution of 2, the x now become 4. So 4 squared minus 4, I guess, to the power 3 out of 3. Then minus 0 being at these places will still produce what? 0. I know this will be 16. 16 times this will give us 32. This will be 64 all over 3. The trick is that use this to multiply this. 90 So I have 96 minus 64 all divided by 3, because this has a power of 1. So the 3, I have a denominator of 1. So 3 times this will give us this. What will I be seeing? This from here will be 3. So I'll be having 32 divided by what? 3. Which I know I'll have my 10. 2 divided by 3. That would be 6. So 6.7. If I'm to round this to, let's say, 3 decimal significant places, 1, 2, 3, that will have been 10.7 square word unit. So this will be the area of the region, the infinite region between the two graphs. That's the two equations. The equation for the quadratic and the equation for the linear aspect. I believe the concept for sketching curve is well understood. You can visit my playlist for the tutorial on how to sketch a curve and how to find the area under the curve. Share this video, like, comment, and subscribe. Bye-bye.